This is a rhombus. A rhombus is a parallelogram where all of the sides are of equal length. I've labelled the length of the sides A. Now let's draw in the diagonals joining each corner of the rhombus. I'll give this diagonal the label X and the other diagonal will have the value of Y. Intersecting diagonals of a rhombus have a unique property, and that is that they will always intersect at 90 degrees. After showing this proof, I'll be making a follow-up video using this property and others to prove that the area of a rhombus can be given by half of x times y, which is an alternative to using the base times the height of the rhombus to find the area. So let's begin formulating this proof. We'll go back to the plain rhombus without the diagonals. The first thing I'm going to do is to add the x diagonal back in. This results in two triangles connected at their bases. Now if you examine the sides of the top triangle, you can see that one side has a length A, another side has a length A, and the base of the triangle is the x diagonal. So the sides of the triangle on the top are A, and X. Looking at the bottom triangle, we have the same thing because the sides are A, and the base is X. So both of the triangles have the edges A, and X. And you should know that when you have two triangles and all of their corresponding edges are the same length, the triangles are congruent. In other words, they're exactly the same size. So these two triangles are the same size. But these triangles have another property. The triangles have two edges that are the same length. And a triangle that has two sides of equal length is an isosceles triangle. So let's mark the edges of equal length on both triangles. Now we know that the two base angles of an isosceles triangle have the same value. Here are the base angles of the top triangle. I'm going to label them with the same letter, B. But remember that these two triangles are exactly the same size, so it means that the base angles of the other triangle must have the same value as the base angles in the first triangle. So now we have two isosceles triangles which are congruent that are attached at the base. For the next step, I'm going to add in the other diagonal line labelled Y. And just like the X diagonal, this diagonal results in two triangles. This is the first triangle, and the second one is pointing in the opposite direction. Let's examine the sides of these new triangles. Starting with the blue triangle, one of the sides is A, the other side is A, and the third side is the Y diagonal. So this triangle has the sides A, and Y. And now if we examine the sides of the other triangle, you can see that it has the sides A, and the diagonal Y. So both of these triangles have the sides A, and Y. So just as with the first two triangles, these two triangles are congruent. They are identical. Again, these triangles have another property, which is that they both have two sides of equal length, A. So both of these triangles are isosceles. For these two triangles, the Y diagonal is the base. In these two triangles, the angles that are opposite the base are split in two by the X diagonal. For both angles, each side of the split is identical, which means that both angles are split exactly in half by the diagonal X. The name for a line that cuts an angle exactly in half is an angle bisector. So for each triangle, the diagonal line X is an angle bisector. Notice that the X diagonal also passes through the base of both triangles. So we have that the Y diagonal is the base of the triangle, and the X diagonal is a bisector that passes through the base. And if you didn't already know, in an isosceles triangle, the angle bisector that passes through the base of the triangle is always perpendicular to the base, which means the angle between X and Y must be 90 degrees. But X and Y are really just the diagonals of the rhombus, so that means that the diagonals of a rhombus intersect at 90 degrees, which is what we set out to prove. So our proof is done. By the way, if you're wondering why an angle bisector that passes through the base in an isosceles triangle is perpendicular to the base, check out my previous video which goes into detail with a proof, linked in the description and the comments section. Also, in my next video, I'll be using this property of intersecting diagonals in a rhombus to prove that a formula for finding the area of a rhombus is given by x times y over 2. So stay tuned. Anyway, that's it for now. Thanks for watching.